Welcome everyone to our webinar on hydrogen compression market landscape. This is the second webinar that we're doing on the topic of hydrogen that we've started researching on at Power Technology Research. I'm Hassan Zahir. I'm the Chief Commercial Officer at PTR. And with me, I have my colleagues, Zishan Khan, who's the Senior Market Analyst for Hydrogen at PTR, along with Jannat Wasif, who's also a Research Analyst focusing on the hydrogen topic in PTR's team. A small housekeeping item, all of you have your microphones muted, but still that doesn't mean you cannot ask questions. So please feel free to use the chat option throughout the webinar as soon as the question comes up, and then we'll make sure that we have the questions there, and then we'll answer them for you in the Q&A section towards the end. I want to start with a very quick introduction of the company for those of you who do not already know PTR. So we are a specialized market research firm focusing on the power grid and new energy equipment. Market research, we provide qualitative and quantitative analysis to our customers across the energy sector's value chain, from component manufacturers to OEMs to investment banks, as well as consulting firms who are looking to make strategic decisions based on the data. But our value proposition is that we specialize in the power grid sector as well as the new energy equipment markets. What do we mean by that? Which exact topics do we cover in our research? So we're looking at everything inside and outside of substation, talking about transformers, switchgear, flexible AC transmission systems, HVDC systems, as well as looking at all of these new energy equipment, which is now interacting with the power grid, from EV charging infrastructure to energy storage to hydrogen to shore-to-ship power systems. So we're covering all of this equipment markets. But then the interesting thing is that we're also looking at the interaction of these things with each other, how the market for switchgear is influenced by the market for transformers because they're installed next to each other. How is the market for flexible AC transmission systems influenced by the market for renewable energy, for example, and all of these factors inside and out. So we basically specialize on these topics that you see on your screen. With that said, I'll move on to the agenda for today. We started with the introduction, very quick introduction for the company. I wanted to save time. We'll start with kind of the background to put things in perspective, to put things in more in a deeper context. So starting with the role of hydrogen in the future energy systems, because there's a lot of debate around that. But then also going into a little bit more detail on the hydrogen compression market, overview of hydrogen compression market, what is the importance, what are the challenges associated with hydrogen compression as a gas, but then get into the applications and the technologies as well. And this would be the initial 15 minutes. And then Jannat will jump into the market analysis of the hydrogen compression part, and then she'll walk you through some of the key findings from our research on that topic. And then towards the end, we'll have plenty of time for Q&A. So any questions that you type in the chat, we'll take them one by one. And move towards that. With that said, I'll hand it off to Zishan to take over the screen and then start presenting.
Good morning and good afternoon, everyone. And thank you, Hassan, for a very lovely introduction. Now, I will kickstart our discussion by exploring the crucial role of hydrogen in shaping the future energy systems. Hydrogen is a versatile and promising energy carrier that has the potential to revolutionize our entire energy landscape. Now, let's explore where hydrogen is currently used and its future potential applications. Currently, hydrogen is primarily used in industrial processes such as refining, iron and steel production, chemicals production such as ammonia and methanol, and power generation. Now, it also has niche applications in the transportation sector, where I believe it can play a significant role in decarbonization efforts. In this sector, hydrogen-powered fuel cell vehicles, which only emit water vapor, offer a clean alternative to traditional internal combustion engines. Additionally, hydrogen can be used in heavy-duty transportation such as trains, buses, and trucks, and this can contribute to a greener transportation network. And another exciting area of potential is renewable energy storage. As we continue to increase our reliance on renewable sources like solar and wind, hydrogen can serve as an excellent means of energy storage. Excess electricity generated from renewables can be used to produce hydrogen through electrolysis. This hydrogen can then be stored and later used to generate electricity or provide heat when renewable sources are unavailable. And this can ensure a stable and reliable energy supply. Now, hydrogen can also be utilized for heat generation in residential, commercial, and industrial applications. By utilizing hydrogen as a clean fuel for heating purposes, we can not only reduce our reliance on fossil fuels, but also significantly lower our greenhouse gas emissions. Furthermore, hydrogen can be enabled to integrate different energy sectors through power to gas technologies. Excess renewable electricity can be converted into hydrogen, which can then be injected into natural gas grids, and we can use for other purposes like synthetic fuel production. These synthetic fuels can be used in powering maritime and aviation sectors. So we can conclude that hydrogen holds tremendous potential in shaping the future energy systems. Its application span across various sectors, including transportation, energy storage, and heating. By embracing hydrogen as a key component of our energy mix, we can move towards a cleaner and a more sustainable future. Now, in the next slides, we will explore the importance of hydrogen compression in the hydrogen value chain and uncover the challenges and opportunities it presents. Hydrogen, with its molecular weight of 2 grams per mole, is the lightest of all gases. It boasts a remarkably high energy content of approximately 33 kilowatt hours per kilogram, which makes it an ideal energy carrier. However, one of the challenges we encounter is the low density of hydrogen compared to other gases, which is approximately around 90 gram per meter cube. Therefore, compression of hydrogen becomes important to meet the various process conditions of different applications. Now, hydrogen compression applications can be categorized into two main groups. The first is pure or 100% hydrogen applications. I will explain it with an example. For example, consider a hydrogen production facility where hydrogen is ideally produced from an electrolyzer powered by renewable energy sources. Once produced, this hydrogen is 100% pure and is compressed and stored to be utilized in a wide range of applications. The second category is hydrogen-rich applications, which is commonly found in refineries and chemical plants. In these plants, recycle or makeup compressors are employed to handle process gases containing high content of hydrogen along with other constituents of process gases. Effective, effective compression ensures the efficient and reliable transportation and utilization of these hydrogen-rich gases. Now, while hydrogen compression offers numerous advantages, it does come with its share of challenges. Challenges to hydrogen compression includes its energy intensive nature. The second challenge that we face is that it requires multiple compression stages to achieve desired pressure levels. High impeller speeds are also necessary for effective compression. And lastly, it is essential to implement measures to mitigate the risk of hydrogen embrittlement and leakage. Now let's embark on an exciting journey through the hydrogen compression value chain, where we will explore the various steps that shape this dynamic process. From production to application, each stage plays a crucial role in harnessing the two potential of hydrogen. We begin at the production stage where hydrogen can be sourced from green or blue pathways. Green hydrogen derived from renewable energy sources like solar and wind represents a sustainable and eco-friendly option. On the other hand, blue or gray hydrogen is produced through fossil fuels. Now, these different pathways provide the foundation for the diverse range of hydrogen sources available. Moving forward, we enter the conversion and processing stage. Here, hydrogen undergoes purification and compression. In this step, we increase its pressure from 20 bar to around 100 to 200 bar. Now, the compression level depends on factors, for example, how long we have to transport hydrogen. It may be further compressed to transport through dedicated hydrogen pipeline or blend with natural gas to transport through existing natural gas infrastructure. Hydrogen can also be stored and transported in alternative form such as liquid hydrogen, gaseous hydrogen, or liquid organic hydrogen carriers. However, this requires high compression levels of around 900 bar. Now let's dive into the world of application. Each industry or sector has its unique requirements in terms of hydrogen pressure and flow. For instance, in the mobility sector, pressure ranges from 500 to 700 bar is essential for its efficient usage. In ammonia and methanol production, pressure typically ranges from 100 to 200 bar. Conversely, conventional hydrogen applications like power generation, oil and gas, refineries, petrochemicals, chemicals, and glass industries typically operate at pressures below 100 bar. As you can see, the pressure is around 7 to 80 bar for these conventional applications, and in the power generation sector, it's around 30 bar to 10 bar. While existing compression technologies cater to these applications, exciting developments are occurring in the market. Emerging compression technologies offer improved efficiency and reduce overall hydrogen production costs, which paves the way for an even more sustainable and cost-effective future. So in a nutshell, we can say hydrogen compression plays a crucial role in unlocking the benefits of hydrogen as an energy carrier. It enables efficient storage, transportation, and utilization in pure and hydrogen-rich applications. Now, I agree that challenges exist, but ongoing research and engineering of innovations are also addressing these issues. Now, in the next few slides, I will discuss the hydrogen compression technologies. Hydrogen compressors are mainly divided into two types, the mechanical compressors and the non-mechanical compressors. Mechanical compressors are further divided into four types, and among those four types, three are established compression technologies. One is the piston compressor, second one is the diaphragm compressor, and the last one is the centrifugal compressor, which is an established compression technology. A new mechanical compressor, which is ionic liquid compressor, is also now available in the market, but it is a relevantly new technology. On the non-mechanical compressor side, we have four further different types, which are metal hydride compressors, electrochemical compressors, adsorption compressors, and cryogenic compressors. Now, all these four types of non-mechanical compressors are emerging compression technologies. Now, in this slide, we will discuss about the existing hydrogen compression technologies, what are their different advantages, disadvantages, and their key market applications. Now, as per our analysis, piston and diaphragm compressors currently lead the hydrogen compression technologies. When we look at the piston compressors, it is a very mature technology with high discharge pressures, and it is adaptable to large range of flow rates. While it has its own set of disadvantages, that it has high vibrations and noise with a very complex designs, and there are risks of embrittlement and contamination by lube oils. Its key markets are chemical plants, petrochemical plants, and refineries. The diaphragm compressors also has high throughput, low power consumption, and less cooling requirements. Some of its disadvantages are again its complex design and risk of diaphragm failure. And its key markets are dry hydrogen refueling stations and chemical plants. When we look at the centrifugal compressors, it has an advantage that it also has a mature technology and high discharge pressures, and it is also adaptable to a large range of flow rates. Some of its disadvantages are its high RPM of the turbine, its moderate compression ratio, and a risk of hydrogen-induced cracking. Its key markets are chemical, petrochemical plants, refineries, and pipelines. Now, when we look at the emerging hydrogen compression technology, efficiency and cost reduction is their primary target. And we believe these pioneering non-mechanical technologies are poised to transform the hydrogen sector. When we individually look at these technologies, ionic liquid compressors have high efficiency and compression factor, and it has less energy consumption. However, it has a risk of liquid leakage, cavitation, and corrosion. Its key market is the hydrogen refueling stations. The metal hydride compressors are also thermally driven compressors which have compact and safe design and has high purity hydrogen at the output. Its disadvantages are its limited heat transfer, low efficiency, its weight and cost of compression elements. Its key markets are chemical plants and power generation. When we look at the electrochemical compressors type, they have low cost operation and high efficiency with no moving parts. It also has high purity hydrogen at the output, and it can be used as a hydrogen purifier. Some of its disadvantages are its high cell resistance, hydrogen back diffusion, and difficult to manufacture cell assembly and relies a perfect sealing. Its key markets are hydrogen refueling stations and power generation. The cryogenic compressors have high hydrogen density, volumetric efficiency, and high gravimetric and volumetric capacities. Some of its disadvantages are its low temperature required for liquefaction and added energy cost due to liquefaction and difficult to manage thermal insulations. Its key markets are chemical plants and refineries. Lastly, the adsorption compressors are also thermally driven compressors with no vibration and noise, no sealing requires, and low cost of adsorbent. Some of its disadvantages are its low thermal conductivity of adsorbents, low temperature operation, and difficulty in thermal management. Some of its key markets are hydrogen refueling stations and chemical and petrochemical plants. Now, this is it from my side, but now I will hand over to Janet to give you insights on global hydrogen compression market. Thank you.
Thank you, Zishan. Hello to everyone. I hope you're having a great time at the webinar. So now I will perform a detailed analysis of the global hydrogen compression market, in which we will look at the global demand centers, some major projects, the leading companies, and also some application and regional trends. So let's start. So the global hydrogen demand reached around 94 million tons in 2021, which translates to around 2.5% of the global final energy consumption. Segmenting this demand into regions and applications, we see that there are some specific countries that are driving the entire global demand of hydrogen compression. In the North American region, Canada and USA come up as the major demand centers for hydrogen compression. And both of these countries have also published their national hydrogen strategies. In its strategy, Canada targets hydrogen usage in the mobility and refinery industries, whereas USA emphasizes on hydrogen usage in the refining, ammonia, and mobility industries. In the South American region, Chile is the only country which is investing a significant amount of time and money within the hydrogen sector and has announced some big projects that utilize hydrogen for the decarbonization of ammonia, refining, and mobility industries. Coming to the European, Middle Eastern, and African region, we see that UK, France, Germany, Spain, Morocco, and South Africa have announced some highly ambitious targets for hydrogen deployment and hence comprise of a notable share of the global hydrogen compression demand. UK targets a broad variety of hydrogen applications such as mobility, refining, blending, and power generation. Whereas France and Germany both focus on hydrogen usage in the mobility, ammonia, refining, and iron and steel industries. Spain targets the ammonia and mobility industries only, whereas Morocco targets the ammonia and iron and steel industries. South Africa emphasizes on hydrogen usage in the mobility, refining, and iron and steel industries. The Asia Pacific region comes up as the largest demand center for hydrogen compression globally. Now, this is due to the fact that China is the largest producer and consumer of hydrogen. The Chinese government targets a wide range of hydrogen applications such as mobility, ammonia, methanol, refining, and iron and steel. Similarly, South Korea and Japan also focus on hydrogen usage in the mobility, ammonia, refining, power generation, heating, and iron and steel industries. Australia targets the ammonia, methanol, power generation, and blending industries, whereas India, which is relatively new in the race to adopt hydrogen, focuses on ammonia, methanol, and refinery industries. If we look at the factors impacting the global hydrogen compression market, we see that several large scale hydrogen projects are driving the growth of the global hydrogen compression market. Contrary to this, there are also a few factors that have the potential to hamper the growth of this market. Let's take a look at some of the major projects around the world. The first one is the European Hydrogen Backbone Initiative, also known as the EHB initiative. This project aims to construct five pan European hydrogen supply and import corridors by 2040. It also aims to construct around 28,000 kilometer pipeline by 2030 and a 53,000 kilometer pipeline by 2040. Now, 69% of this pipeline is expected to be repurposed natural gas pipelines, whereas 31% of these pipelines are going to be entirely new hydrogen pipelines. The second project is the H2 Med Pipeline project, which is the first major hydrogen corridor connecting the Iberian Peninsula with the rest of the Europe. This project will comprise of a 703-kilometer long pipeline, which will transport around 2 million tons of green hydrogen per year. The next project is the HYNet Northwest project. Now, this project aims to produce 2,160 tons of hydrogen per day by 2030. It will comprise the storage and transportation of compressed hydrogen to be used in the refinery, power generation, and blending industries. Another project is the European Hydrogen Hub project. Now, aims this project aims to produce around 3,180 tons of hydrogen per day by 2060. It will comprise of the storage and transportation of compressed hydrogen to be used in the mobility, refinery, chemicals, power generation, and blending industries. Another project is the Wyoming Clean Power Center project, which aims to produce around 160 tons of hydrogen per day by 2060. This project will also comprise the storage and transportation of compressed hydrogen, which is going to be used in the refining, power generation, and blending industries. If we look at the factors that have the potential to disrupt the hydrogen compressor value chain, price volatility tops the list. Since the oil and gas industry is a major contributor to the global hydrogen compression market, uncertainties in crude oil prices can negatively affect the investments in the oil and gas industry, which will in turn reduce the sales of hydrogen compressors. The next factor is the unforeseen disasters and lockdown. As we all saw during the COVID-19 lockdown imposed in several countries around the globe, numerous manufacturers in the worldwide hydrogen compressor market had to halt their business production. And this disruption led to a direct impact on the sales of hydrogen compressors. Similarly, oil contamination can result in severe consequences such as spoiled or unsafe products, production downtimes, and legal issues. Moreover, since hydrogen is a very hazardous gas, any accident in the value chain has a potential to disrupt the market. Similarly, threat of premature wear, presence of moving parts, and hydrogen embitterment can cause risk and reliability issues. Moreover, the high purchasing and maintenance cost of hydrogen compressors also has the potential to hamper the growth of the market. If we look at the hydrogen compressor application trends in the global market, we see that conventionally, the oil and gas sector has held the largest share of the hydrogen compression market. This is due to the fact that over the years, there has been a surge in demand for cleaner fuels, such as hydrogen. Moreover, rise in government regulations for the desulfurization of petroleum products and increase in demand for hydrogen in oil refineries to remove impurities and contaminants has contributed significantly to the hydrogen compressor demand from this application segment. Moving forward, the hydrogen mobility sector, especially the road transportation segment, is expected to emerge with a significant market share of the global hydrogen compression market. Now, this is due to the fact that hydrogen compressors are required at hydrogen refueling stations, and due to the rapid increase in deployment of hydrogen fuel cell vehicles, an abrupt increase in the construction of hydrogen refueling stations is seen. The hydrogen mobility market is also supported by some ambitious targets for fuel cell vehicle deployment and construction of corresponding refueling infrastructure announced in national hydrogen strategies, and some government regulations mandating the construction of hydrogen refueling stations. There is another application that is slowly making its way in the global hydrogen compression market. It is basically the hydrogen storage and transportation application segment. Hydrogen compressors will be required in great numbers in the future to transport hydrogen through tube trailers, pipelines, and at import and export terminals, which will greatly contribute to the demand of this product. Now, if we compare some stats, we will see that in 2021, the oil and gas sector held a 58% share of the global hydrogen compression market. It was followed by ammonia production at 10% and hydrogen storage and transportation infrastructure at 7% of the global total. According to Peter's analysis, by 2030, the oil and gas sector is expected to have a 32% share of the global hydrogen compression market, with mobility coming at par with a 21% share, followed by storage and transportation infrastructure with a 13% share of the global total. If we look at the leading regions, we will see that the Asia Pacific region comes up as the epicenter of hydrogen compression market. This is because the race to establish low carbon hydrogen production bases in this region is heating up, with a lot of Western and regional companies cooperating on some massive projects to produce the next generation clean fuel, which is hydrogen. For example, the European company BP is the largest shareholder in Asian Renewable Energy Hub, which is a huge Australian project. Similarly, Chevron but Tamina and Keppel Corporation are cooperating on producing green hydrogen using geothermal energy. Moreover, Ørsted and POSCO are also conducting a feasibility study for green hydrogen production and supply of hydrogen steel. There is also a growing demand for hydrogen refueling stations in this Asia Pacific region that is going to drive the hydrogen compressor market of this region. South Korea, China, and Japan are among the top four largest markets for FCVs globally. This region has the highest number of fuel cell vehicles on the road, which makes up 67.4% of the total global. Similarly, this region also has the largest share of hydrogen refueling stations globally, which translates to 59.5%. This region also has another advantage that it is home to the leading fuel cell manufacturers around the globe. Hyundai, which is based in South Korea, and Toyota, which is based in Japan. According to the Hydrogen Council, the combined hydrogen demand of China, India, Japan, and South Korea alone will reach 285 million tons in 2050, which makes up 43% of the global total. This is due to the fact that China is the world's largest producer and consumer of hydrogen. There is also a presence of technologically advanced industries in China and Japan. There is an increase in renewable energy projects owing to government investments in the region. There is also an increase in focus on developing regional and global hydrogen supply chains. Moreover, this region also focuses on the targeted use of hydrogen in multiple sectors. So, all of these factors are contributing towards the largest share of Asia Pacific region in the global hydrogen compression market. If we again compare some stats, we will see that in 2021, the Asia Pacific region held the largest share of the global hydrogen compression market, which was 50%. This region was followed by North America at 20%, Middle East and Africa at 15%, Europe at 10, and South America at 5%. Now, according to PTR's analysis, the Asia Pacific region is expected to have a 58% share of the global hydrogen compression market by 2030. This region will be followed by North America at 19%, Middle East and Africa at 12%, Europe at 8%, and South America at 3%. Now, if we look at the leading companies of the hydrogen compression market, we see that currently the global hydrogen compression market is being led by the following 10 companies: Siemens Energy, Atlas Copco Group, Baker Hughes, Newman and Esser Group, Burkhardt Compression, Sundyne, PTC Machines, Ariel Corporation, Howden, and Ingersoll Rand. It is seen that almost all of these companies are manufacturing the established hydrogen compression technologies, such as reciprocating piston, reciprocating diaphragm, and centrifugal compressors. If we look at the targeted markets of these companies, we see that Siemens Energy provides hydrogen compressors solely for the energy based market, whereas Atlas Copco Group provides hydrogen compressors for storage, transportation, refinery, and power generation industries. Baker Hughes again provides hydrogen compressors to be used only in the energy markets, whereas Newman and Esser Group provides hydrogen compressors for mobility, heat, storage, and transportation segments. Burkhardt Compression also provides hydrogen compressors for energy, transport, refinery, chemical, and petrochemical industries, whereas Sundyne also provides compressors for transportation, refinery, chemical, and power generation industries. PTC Machines provides hydrogen compressors only for the hydrogen mobility segment, whereas Ariel Corporation provides hydrogen compressors for transportation, refining, and chemical industries. Howden provides hydrogen compressors to be used in the transportation, power generation, chemical, and petrochemical industries, whereas Ingersoll Rand provides hydrogen compressors for the transportation and power generation industries. So that was all from my side. In the end, I would also like to give you an overview of the hydrogen services being offered by PTR. We have a global hydrogen projects database, which contains a very detailed description of over 700 operational and pipeline hydrogen projects around the world. We have a global hydrogen market outlook report, which provides a very comprehensive analysis of the entire value chain of hydrogen. Furthermore, it also contains a description of 29 national hydrogen strategies, 39 hydrogen valleys, and 30 company profiles of fertilizers, compressors, and fuel cell manufacturers. We also have another project, which is the Global Hydrogen Compressor Market Sizing Database. This product has been launched this month, and it provides a growth forecast of the hydrogen compressor market from 2021 to 2030. And this forecast is basically segmented into categories and subcategories that differ on the basis of region, technology, and applications. So that was all from my side. Thank you so much for taking out time to attend the webinar. Back to you, Hassan.
Thank you so much, guys. Um, I can see already there's a lot of questions from the audience. Please feel free to type any other questions as well because we have a good 20 minutes left in the scheduled time. But I guess we can start to take the questions in the chronological order. The first question I have is from Christian about which compressor technologies are commonly used in the mobility or storage applications where high discharge pressures are required.
Thank you, Hassan, for your question. I think so. The question is around the mobility sector. What we have seen naturally that diaphragm compressors is the most prevalent technology in the mobility sector because of the higher discharge pressures that are required. Plus, purification is also an important factor in the mobility sector. And since we have the start and stop functions, quick start stop functions in the mobility sector at mostly at the hydrogen refueling stations. So what we have seen is that most of the companies are targeting the diaphragm compressors for this particular application.
Okay, then we have another question from Edwards. Which of these emerging technologies can also be used for CO2 compression in CCUS, carbon capture applications?
I can answer that. I think electrochemical compressors would be the most prevailing one for carbon dioxide compression, owing to their higher efficiencies and noiseless operations.
Okay, then we have a third question from Robert. In your opinion, what type of non-mechanical hydrogen compressors do you believe will be the most prevalent in the future?
As Janet has mentioned that we have seen that with the in the non-mechanical compressor side, we have seen that electrochemical compressors will be the most prevalent, and there are particularly two main reasons of that. One is that they have high efficiency. With the mechanical compressors, we have seen that the average mechanical efficiency is around 45%, but what we have seen is that with the electrochemical compressors type, they have achieved the efficiency of around 60% and high discharge pressure of around 1000 bar. Having said that, it's not, let's say, we have not seen so much uptake of these type of compressors in the market, but we feel that with more investments being done in this market and with the growing hydrogen demand, we think that this technology will be the most prevalent one. And one other advantage of this technology is that you can also purify the hydrogen. You don't need a separate purifier. With these compressors, you can purify the hydrogen along with compression. So we believe with all these advantages that it has not only in the non-mechanical compressors, competitive non-mechanical compressors technologies, but also with the mechanical compressors technologies, electrochemical compressors technology will be the most prevalent in the future.
Mhm. Okay, then we have the next question from Joanna or Joanna. What is the highest flow rate achieved by reciprocated compressors in a hydrogen environment?
Um, I think, as far as I know, the highest flow rate that has been achieved using reciprocating compressors would be 890 kilograms per hour at a maximum pressure of 25 megapascals. This is for hydrogen.
And just to
Okay.
add on it, if you increase the pressures, then the flow rates will low down. But at 25 MPa, that's the highest flow rates that they've achieved.
Okay. Then the next question from Jennifer. Apart from projects, what other factors have the potential to drive the growth of hydrogen compression market?
I would like to answer that. Well, apart from projects, some other factors can also affect the hydrogen compression market. For example, the growing hydrogen demand. We've seen that over the years, the global demand for hydrogen and its derivatives has greatly increased, and it is going to keep on growing and experience significant growth in the coming years. Similarly, there's the investments in the hydrogen sector. They also play a major role here, especially with some new companies entering the market and some existing companies that are expanding their operations. And another factor that I would also like to highlight here is the role of national hydrogen strategies in supporting policies. So, till date, 31 countries around the world have published their national hydrogen strategies and for the deployment of hydrogen technologies. And these strategies, combined with some supporting hydrogen friendly regulations and policies, all of these factors can impact the growth of the hydrogen compressor market.
Okay, then another question from Jennifer. I think more of a clarification question is that what is the role of hydrogen compression compressors in the green hydrogen production?
Okay, so green hydrogen production basically means hydrogen production using electrolyzers. So, hydrogen compressors are basically used to increase the pressure of hydrogen gas, and as the pressure of hydrogen gas increases, basically its volume decreases. Means you can store a large amount of hydrogen gas at a very small volume. So, like this is the basic working principle. So, during green hydrogen production, using electrolyzers, hydrogen is produced at a very low pressure. So compressors are basically used to increase the pressure of hydrogen to make it suitable for transporting hydrogen and also storing it. And we can store hydrogen at around 100 to 200 bar, and the transportation pressures depend upon the type of transportation technology being used.
Mhm. And just to add on it, as Janet has mentioned, at the downstream of electrolyzer, normally the prevalent technology of electrolyzers has been the alkaline type, and we have the discharge pressures of around 5 bar. And then we have this PEM electrolyzers, which or have the discharge pressures of 30 bar. But as you have seen in our previous slides, that at the end use applications, the requirement is very high. So that makes this hydrogen compression very essential in all the existing applications and the emerging applications. So we believe that hydrogen compressors are an integral part of this value chain and this green hydrogen market in the future.
Okay, then we have next question from Milos Bahik. Do you expect non-mechanical hydrogen compressors will become competitive to mechanical in the near future?
Janet, are you going to answer? Or?
Can answer.
Okay, I think so. As I've mentioned, among the non-mechanical compressors type, electrochemical compressors will be the most prevalent, and we have seen um, uh, this compressor technology taking a lot of advantages. I have explained in the previous answer of the question. Well, in the mechanical compressor side, this new ionic liquid compressors are also, let's say, take the lead because of their high discharge pressures, and we have seen some companies coming up with this ionic liquid compressors, and they are installing in the hydrogen refilling station. So among mechanical compressors, especially for the refilling applications, ionic liquid compressors may take the lead. And when we talk about non-mechanical compressors, I think so electrochemical compressors technology will take the lead. Although, let's say in the cryogenic applications, we have cryogenic type and adsorption type is also under research and development, but the results are yet to be seen. But for the electrochemical, the results are already very promising, and we see a lot of its installment in the future projects.
Okay, next question from Tom Young. Will liquid hydrogen supply chains develop alongside compressed hydrogen supply chains?
To answer this question, with the liquid hydrogen, although there are many advantages, let's say we can because of its low volumetric density, if we compress the hydrogen and make convert it into the liquid phase, a lot of challenges can be overcome, but there is a cost associated to it, and then you have this very low temperatures to convert hydrogen into the liquid phase. In my opinion, firstly, you need to develop the hydrogen compressors market, and then you can move towards the liquid hydrogen market. It won't develop in parallel, but once you have a developed hydrogen compression market, maybe you have, let's say, chances of developing the cryogenic type, liquid organic hydrogen compressors type, or the gaseous hydrogen compression market.
Yeah, I think you answered the next question in the same question to some degree as well. We can move to the question from Joanna. What is the highest speed in centrifugal compressors achieved in hydrogen applications?
It's not at the top of my head right now. Maybe I can answer you later on. But coming towards the centrifugal compressors, they have been traditionally used in the oil and gas applications, and where you have high flow rates required. It is not for the pure hydrogen application. It's for the, let's say, hydrogen rich applications where process gases are involved, and their applications has been traditionally in the oil and gas sector. Now, there are many challenges associated with the centrifugal compressors to be used in hydrogen rich applications. Uh, we don't believe that for the hydrogen rich applications, these type of compressors will be used in the coming years. Just one, let's say, end use application that we feel where centrifugal compressors may come in place after overcoming these design challenges, let's say, of the speed and everything, and since because there are a lot of stages being involved in the centrifugal compressors, once you overcome these design challenges, then maybe you can use it in the pipelines, let's say, where long distances are involved and you have very high volume of hydrogen uh, involved. Uh, on the speed side, I maybe shoot you an email. It's not at the top of my head right now.
Okay, and then we have last question from Christopher Durand. What types of compressors are better for lifting hydrogen from very low pressures from alkaline electrolysis?
As I said, it.
For Okay,
Go
I
ahead,
think
Janet.
for electrolyzers, traditionally alkaline and PEM electrolysis, traditionally we use diaphragm compressors and piston compressors, and both of these are reciprocating compressors. So that is preferred for hydrogen production using electrolysis.
Mhm. And just to add on it, it depends on the end use application. Let's say if you're using it, if your end use is around 750 bar, probably your first choice is going to be the diaphragm compressors, and then you have the purity requirements. But if you are going to use it in the oil and gas sector, maybe you can use the centrifugal compressors where purity is not the requirement, where you don't need very much high pressures, you just need high flow rates, as in the oil and gas sector. So maybe you can use the centrifugal compressors type. So it depends on the end use application. What are your requirements of the flow, of the pressure, of the purity, and then you can decide on the certain type of compressors that are going to be used.
All right, amazing. Thank you so much, guys,
Thank you.
for all the engaging questions. And thank you so much to you, Zishan and
Mhm.
Jannat, for a very engaging webinar as well. If you guys have any other questions that come to your mind later on as well, please feel free to shoot me, Zishan, or Jannat an email. Our email addresses were there in the start of the webinar, but then also we will have this available on demand to be viewed later on as well. So please be on the lookout on the email from our side if you're looking to see this later on or to share it with your colleagues as well for on-demand viewing. Thank you once again, and depending on where you are in the world, have a good rest of your day or rest of your evening. Have a nice day.
Thank you.
Bye bye.
Thank you. Bye bye. Thank you, everyone.